Okay, this is another question that we've got, and it's a longer one. It's got 7 parts to it, and it's got a little picture of a fractionation setup where they're using distillation. So they're distilling, so they heat up a crude sample, and then it boils, and it'll start condensing, and they separate out the fractions. So it says here that a student is tasked with separating crude mixture of hydrocarbons. The sample contains 2,2-dimethylbutane, so you've got 2,2-dimethylbutane. It's saturated, so it's C6 because it's got 2 methyls and a butane, which is a 4, and so it's going to be H14. And then you've got 3,3-diethyldecanes, so 3,3-diethyldecane, and so decane's 10. And it's got 2 ethyls. So it's going to be C14H30. And then you're going to have 2,2,3-trimethylpentane. And so you've got 3 methyls, so that's 3 carbons and 5 more. So this will be C8H18. So those are the 3 things that are in our crude sample. The simple distillation apparatus shown below will be used to separate the crude mixture of hydrocarbons. So which property does distillation apparatus use to separate the crude sample? It's going to use boiling point. And so whichever chemical has the lowest boiling point will boil first, and then they'll condense it and remove it. And then they'll get the next sample to condense, and they'll put a different flask, and they'll collect it. And then the third flask will contain the third chemical. So the chemical that will be collected first is the smallest chemical. And so this has the lowest London dispersion force. This is a good predictable comparison because these are all branched alkanes, and this is by far the smallest alkane. It will have the lowest boiling point. It will be collected first. So draw and name 2 isomers of 2,2-dimethylbutane. So if I've got 2,2-dimethylbutane, it doesn't say the kind of diagram, so you could draw your diagram like this. You could have a pentane that has a methyl, so that'd be a 2-methylpentane. You could have 3-methylpentane. 4-methylpentane would be the same as this, so it's not an isomer. And then you could also have a hexane, right? Because these are all C6H14. Those are all isomers of one another. It then says, if the student reacts 2,2-dimethylbutane with chlorine gas in the presence of ultraviolet light, what are 2 expected products of the reaction? Now, this is a bit of it's a very different kind of question, and so that's fine. The first thing that we want to recognize is that this is a substitution reaction. We're reacting chlorine gas with a branched alkane. Now, this chlorine has a Cl, and this chlorine could substitute any of the hydrogens in this. So there are lots of possible products. I'm going to substitute off of this carbon and put a chlorine there. And that'll be one of my products that I'm going to choose. And this would be a 1, 2, 3, 4, so it's a butane. It's a 2,3-dimethyl, and it's got a 1-chloro. So it'll be a 1-chloro, 2,3-dimethylbutane. And importantly, the question asked for 2 products. Now, it didn't ask for isomers, but those would be reasonable answers. You could have substituted one of the other hydrogens out for a chlorine. But in a substitution, this chlorine is going to bond to the hydrogen that also came off of it. So hydrogen chloride is another possible product. You could, or it must be produced. You could have the chlorine bond here, and you'd get an isomer produced, and it'll also produce an HCl, right? So in this case, this would be a 2-chloro-2,3-dimethylbutane. So lots of options for that as potential answers. What is the original source of energy for the production of 3,3-diethhyldecane? And this is meant to be a really straightforward question, but all the energy on the Earth comes from the sun, and so its original source of energy is the sun. If the crude mixture was originally from the oil sands, what other refining would be needed to make the oil sand into the crude mixture? So if I wanted to take oil sand and make it into crude oil, so that means that it hasn't been fractionated yet, it's just still pretty crude, I need to remove the sand, right? So the oil is attached to the sand, so they probably are going to use some heated or even boiling water to increase or decrease the viscosity of the crude and try to get off the sand. They may use some sedimentation to try to get the sand to settle out because it's denser, and they could even use some centrifugation. So you're supposed to understand the steps to be able to remove things or to separate the kinds of organic molecules, and so it's easy to forget those things. If the crude mixture was originally from heavy crude well, what other refining would be needed to make the oil sand into the crude mixture? So if it's heavy crude is difficult to remove. So they're probably going to need to do some steam injection or use some water injection of some sort, heated water injection, because that heavy crude is so dense that it doesn't flow very well. It's kind of like cold honey or cooled down molasses, that it eventually becomes so thick and viscous that it doesn't flow well enough. You can't pump it out of the ground. So that's kind of what it's trying to drive at.